Welcome back, everyone. So, you're done with paper 4 of physics recently. Now, in about a week's time, you have your paper 5, which is going to be, I think, on 19th or 20th of May. I'm forgetting that. But now, what I want to do on my YouTube channel here is to create a guide on how to solve paper 5. Obviously, you should practice as many past papers as you can, but it's also important to understand how to go about solving the two questions that you get in paper 5. So firstly, what I want to do is make an entire playlist consisting of short videos which helps you explain how to solve each part in question number 2. So this video will be an overview of question number 2, how the marks are allocated across each of the parts in question number 2, and then we are going to take a look at an example of a paper which is from the recent years and how the marks are allocated and what the structure of question 2 is like. Then I'm going to make detailed videos on each part about how to go about solving each of those questions. So let's jump into the screen. Okay, so here we can see a breakdown of marks for question number 2, which is provided by Cambridge. By the way, this screenshot is taken from a file which Cambridge has made available on their website. So that's where I've taken the screenshot from. All this information is available for free on their website. Now you can see in the picture that the question number 2 consists of total 15 marks, but the marks are divided across 5 different skills. The minimum mark allocation for each skill is given on the rightmost column. You can see data analysis is of 1 mark, where basically you have to rearrange an equation to understand what will be an expression of the gradient or the y-intercept. So that has minimum 1 mark. Then you have to complete a table of results. We have to find some values, calculate some data, find its uncertainties. That has a minimum of 1 mark as well. Then you have to draw a graph, draw a line of best fit and worst fit, and find uncertainties in gradient and intercept. So that has a minimum of 2 marks as well. Then we have the conclusion part, which where you have to calculate some unknown constant from your previous answers, and that has a minimum allocation of 3 marks as well. And last but not the least, it's the treatment of uncertainties. Now, treatment of uncertainties is not allocated to just one part of the question, but it's basically spread out throughout the question. So when you calculate values in the table, you also have to calculate the uncertainty in one of the columns for all the rows in the table. So you usually have 1 or 2 marks allotted to uncertainties from there. And then when you are doing the conclusion part, where you're finding an unknown constant, or when you're finding your gradient, or when you're finding your y-intercept, you might also have to find uncertainties in those parts. So uncertainties are allotted a minimum of 3 marks. Now you will notice that these 5 skills add up to just 10 marks. So why is the question of 15 marks? Well, look at what's written below. The remaining 5 marks will be allocated across these 5 skills in the grid, and their allocation may vary from paper to paper. So these marks in the rightmost column are minimum allotted marks for each of the skills, and the remaining 5 will be added to these in a different manner from question to question. Now we'll take a look at an example, and this example is from October-November 2020, paper 5-2, and here you have a situation given where a student is trying to investigate the relationship between this variable d and this variable h, and the equation for that relationship is suggested below. Now the first thing that they want to do is draw a straight line graph using this equation. So they'll tell you what is plotted on the y-axis and what is plotted on the x-axis. In this case, h is plotted on the y-axis, 1 over d is plotted on the x-axis, and that will give us a straight line graph. Now, first part, you have to find the gradient, the expression of the gradient. You don't have to find the value of that gradient. So in this equation, what represents the gradient of the graph? So I'll be making a detailed video on how to deal with different types of equations, how you can rearrange the equation in order to find the expression for the gradient as well as the y-intercept. I will also be talking about equations which includes logs or natural logs, where there are exponential equations and you have to use logs or natural logs to get a straight line graph out of them. So the link to that video will be given in the description as well as in the top right hand corner. Then the second part is about a table which is incomplete, and you have to complete the values in the table by doing some calculations. After that, you have to find some uncertainties in the table as well, and I will be making a detailed video about how to complete the tables, how to deal with uncertainties in question number 2 as well. So you will see the link to that video in the description as well as in the top right hand corner as well. Part C will be mostly dealing with the graph. So you have to plot the points, you have to draw the error bars, you have to draw the line of best fit, you have to draw the worst acceptable straight line, then you have to find the gradient or the intercept. You also have to find uncertainties in your gradient and intercept. This is where you plot your graph. You can see that the axes are already labeled with correct quantities and units, and the scale is also chosen for you, so you don't have to do that part here, which is good. Then in part D and E, you will be dealing with conclusion as well as uncertainty. So you might have to find some unknown constants using your previous answers. For example, part E says use your answer to part A, part C, part 3, part D to determine the value of the constant sigma in the equation. So you have to do that. Then you also have to include an uncertainty in your answer. And then you have to, in part F, you might have to calculate some unknown value using the same equation that is given initially. Again, you will have to calculate uncertainties in almost every part of the question. So I will be making detailed videos about how to solve each part of this question, what tips and tricks you should know, what skills you need to have. So we'll look out for those videos, and I'll see you in the next one.